So continuing in chapter 4, we're now up to section 4.5. In the last video, pardon me, in the last video I made a slight mistake just in that I thought 4.5 was a different section than it is. 4.5 is not finding roots of polynomials, it's polynomial and rational inequalities. It's still a section that has caused students some confusion in the past, so do pay attention. Really, the main objective here is just solve inequalities, either of polynomials or rational functions. So you can graph a polynomial in order to solve it. This is not the best way to do it because it presumes that you, A, have a graphing calculator. Fine, most of us have one available, and B, know how to use it, and that's a tougher challenge than you might think. A lot of students think they know how to use their calculator, but when it starts doing things that they aren't expecting, because they never learned how to do these problems by hand, they can't really tell if it's working correctly or not. But if we just graph this function, x plus 4 times x minus 3 squared, and try to see where it's positive, we can just look here. We solve for the roots, which will be at -4 and 3, and then we can conclude that the graph is positive in between the two roots and then also to the right of that second root. But really, we don't want to do it graphically. Again, as I've said, using the calculator is fine, except if that's all you can do, then really that's all you have learned is how to use a calculator. And this is not a course on how to use your calculator. It's a math class. You have to learn how to think. So let's try to solve the inequality x to the 5th is bigger than -x squared algebraically and graph it. So always, 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 step 1, whether it's a rational or polynomial inequality, rearrange the inequality so that one of the sides is 0. The way the book phrases this is put 0 on the right. It doesn't really matter as long as you have a 0 on one side. Okay, so here, if we add x squared to both sides, we get x to the 5th plus x squared is positive. Notice that what we now have is a polynomial that we are comparing either bigger or greater than or less than, depending on what we started with, 0. That's where you want to end up. Okay. This is really the same problem, just by adding x squared. Because now that you're comparing a polynomial to 0, you can find the zeros of the polynomial. So set it equal to 0 and try to find all the roots. Notice you can factor an x squared out of the whole thing, which means either x squared is 0 or x cubed plus 1 is 0. Now, there is a formula for factoring the sum of cubes. This is x cubed plus 1 cubed. Perhaps you don't know that formula. I don't off the top of my head. So we'll end up erasing this to finish out the way the book did it. But how would you solve this? You'd say either x squared is equal to 0, in other words, x is 0, or x cubed plus 1 is 0. In other words, x cubed is equal to -1. Now, one solution is that x equals -1. But that's not necessarily the only solution. It just happens to be one of them. Also, this gives you a factor of x plus 1. But notice that this right here, x cubed plus 1 is degree 3. This factor is just of degree 1. So we have an issue here. These can't be the same thing. And if you try to do something like, well, make it a root of multiplicity 3, this is not x cubed plus 1. Okay, if you distributed this all out, what you'd get is x cubed plus 3x squared plus 3x plus 1, which is just different than what you started with. Okay, so we are trying to factor x cubed plus 1. And what we've determined is that x cubed plus 1 does have a factor of x plus 1, but then we're not sure what the other thing is. But notice if I divide both sides by x plus 1, our mystery term is exactly what that quotient is. So let's determine what that quotient is by doing polynomial long division. So we take x plus 1 and we're trying to divide it into x cubed plus 0x squared plus 0x plus 1. I have to multiply this by x squared. Gives me x cubed plus x squared. Subtract. Leading term cancels out. I have -x squared plus. I need to multiply by a -x. Gives me a -x squared minus x. I need to subtract that. The biggest term cancels out. We just get an x plus 1, which is exactly 1 times that. Whoops. And now everything cancels off, and there's no remainder, which means that x cubed plus 1 over x plus 1 is exactly x squared minus x plus 1 with no remainder. And if I then multiply this denominator back to the other side, we get exactly this factoring right there. So if you know a root of a polynomial, you can factor something out and find what's left. So since we found a root of x cubed plus 1 was -1, then when I factored out the corresponding, so a root of x cubed plus 1 was x equals -1. So there's a factor of x minus -1, aka x plus 1. And when I factored out by long division, we got this other bit, x squared minus x plus 1. Okay, so continuing. So in order for this product to be 0, one of the pieces has to be 0. In other words, x is 0 or x is -1, coming from this and this respectively. You can use the quadratic formula to see that this quadratic has no real solutions, so the only roots are 0 and -1. So that means if I'm going to try to graph the function x squared times x cubed plus 1, it's going to have a root at -1 and a root at 0, but that's it. So I have divided the interval into these 3 pieces, everything up to -1, everything in between the roots, and everything to the right of 0. And then I can use some test values to determine where it's positive and negative. And just by testing, for example, at -2, we get a negative value. At -1/2, we get a positive value. At 1, we get a positive value. So we've determined, I'll end up erasing this in a second, that everything to the left of -1 was negative. In between 1 and 0, it was positive. And to the right of 0, it was positive again. Right. Okay, here it was equal to 0. Here it was equal to 0 because these were roots. And the question that we started with was, where was x to the 5th bigger than x negative x squared, which turned out to be the same as where is x squared times x cubed plus 1 bigger than 0. And now we know it's exactly from -1 to 0 and then from 0 onward. From -1 to 0 or 0 onward, that's where the original inequality is satisfied. So basically, taking the stuff we already were doing in graphing polynomials and in graphing rational functions ultimately, one of those steps was let's determine where the thing is positive or negative. And if we can always change our inequalities to be about where are things compared to 0, we essentially already know how to do these problems. There's not a lot new going on here. Okay. So there's the graph. Notice that x equals 0 is not included. If you let x equal 0, you get 0 is larger than 0, which is false. So it's true on the interval and then past 0, but not actually at 0. Okay, so as I mentioned, the basic technique is make sure you change the problem to be comparing something to 0, and then all the stuff we've already learned comes into play. So I'll stop this video here, come back for more examples.